It's common with many languages that once a basic array is created, it cannot then be resized. You can create it with however many elements you need, continue to change the value of those elements, but you can't add new elements or remove elements from it. Now, there are exceptions. For example, the standard array in JavaScript is already resizable. The standard array in Ruby is resizable. But most languages provide some kind of resizable array behavior when you need it. The terms you might hear is that it's a resizable array or dynamic array or mutable, meaning changeable array, as opposed to an immutable or unchangeable one. Now, here's a couple of examples of this. In Java, the standard array is fixed size and a fixed data type. So it's an array of integers or an array of booleans. Java being an object-oriented language, you can also create arrays of objects like strings. But for a resizable version, Java offers a couple of classes, the best known being the array list. So instead of creating an array, we create an array list object. That's a different kind of syntax, as array list is not baked into the core language itself. It will require us to link to an external framework and instantiate this as a regular object. Array list can be created totally empty or given an initial capacity, even some initial values. But after this array list is created, and I've called this object resizable, we can use methods to add to it, which we simply can't do with the standard array. And we also have methods to remove from it. As the equivalent example in Objective-C, well, Objective-C is built on top of C, so we do have the standard C-style array, but in day-to-day usage, it's much more common for Objective-C developers to use the class called NSArray for dealing with arrays of objects. Now, if you're new to Objective-C, again, don't worry about the syntax here. This is not the point of this section. I'm simply using the shorthand that creates a fixed size array here of 3 strings. Now, most of the common classes and behaviors in Objective-C programming have this NS prefix. It's a throwback to when Objective-C was used for developing the Next Step operating system that the Macintosh OS is built on. So this NS array, like the standard Java array, is also fixed size. It's an immutable array. You can create it to hold as many objects as you need, but you can't add or remove once it's been created. But just as Java has the array and the array list, in Objective-C we have NSArray and NSMutable array, which behaves identically to NSArray but adds additional methods. And this is a model you'll see across several programming languages, that data structures with what you might think of as slightly different behavior are actually implemented as completely separate classes. Whenever adding new elements to a resizable array, we have a very important decision to make. Are we adding this new element at the very end of the existing array? Are we adding it at the beginning or somewhere in the middle? Now, this matters because typically adding a new element at the end is easier, faster, and requires less work for that array to do. So if we have some kind of method or function that will just allow us to add a value, this just gets added in right at the end with an index number 1 higher than the existing final index number. But on the other hand, if we have that existing array and we want to add a new item somewhere else at a specific position, let's say we're going to add the value 999 at position 2, it will require things to be shuffled around. We'll have to move some of the elements and reorganize them and renumber those positions in the array. This is possibly a handful of pieces of data, but it could be hundreds or thousands before we can fit the new one in. It's certainly true that the resizable arrays we're talking about, like array list in Java, an NSMutable array in Objective-C, or the built-in ones in Ruby or JavaScript, well, they will automatically take care of this, of shuffling these items around. But just because something is happening in the background doesn't mean you can ignore the fact that this does have a performance impact, and the larger the array, the more items will need to be shuffled around and re-indexed. How this reshuffling is actually implemented under the hood differs from language to language. If the array isn't large, some will attempt to reshuffle items in place, but others will just copy the entire contents of the old array into a brand new array, reorganizing things as they go. Now, across languages, there are a few different terms for adding items to arrays, and we often need to include the distinction of where we are putting this new item. So if we are appending item, meaning we're adding an item at the end of an existing array. In Java, the method is just add. In Objective-C, it's add object. In JavaScript, the behavior is called push, and this is quite a common term for adding an item to the end of a data structure, that we push the new item onto the end. In Ruby, we also push items onto the end. Not written here, but in C++, where the vector is our resizable array, the method is called pushBack. In Python, we're technically working with a data structure called a list, not an array, but still, the equivalent behavior is to append to the end of that list. However, if we want to add this new item not right at the end, but at a specific position in the existing array, we're not pushing on to the end anymore. We may need a different word. So in Java, the method is still just add, but we'd also provide an index for what position in the array this new item should be added so it can reindex the other items. In Objective-C, it's still add object, but we also need to provide an index parameter. In Ruby, well, we're no longer pushing onto the end of the array, so we don't use push. We use insert to insert a new item in a specific position, and likewise, we also use insert in Python. Now, in JavaScript, we switch from push to the term splice. Splice lets us split an array at a specific position, inserting a new element, optionally removing some elements, and rejoining that together. Now, okay, we're in danger of a my eyes glaze over moment, so understand I'm not trying to have you memorize every keyword for doing this. More to drive home that the same functionality exists in every language you'll encounter, but it just may have a different name. When adding new items, it's usually a variant of add, insert, or push. Now, when you're removing an item from an array, it's usually some variant of remove, delete, or pop, although pop is the flip side of push, meaning that we push an element onto the end of array, we pop an element off the end of the array. So several languages, JavaScript, Ruby, and C++, Python, they use pop. Pop always refers to deleting the final element off an array. If you want to delete an item that's not the last element, you need some way of passing in the index number. So with Java, it's remove with the index parameter. With Objective-C, it's remove object at index, and so on. Now, okay, I get it, folks. This might seem like overkill, and if this information was only relevant for working with arrays, I wouldn't go into it as much. But this is the beginning of understanding that in all the data structures we'll encounter, there's really only 5 things, 5 fundamental behaviors we might need to figure out. And that's how to access, how to insert, how to delete, how to find, and how to sort. So how do we access? How do we get to the values in this data structure, whether that's getting to one specific element or wanting to iterate through all of them to systematically loop through every element? Then there's how do we add a new item to this data structure, often including, as we've seen, how we would add an item at a specific position. The flip side of that, how do we delete or remove one, whether from the end or from a particular position? Then there's how do we find or search that data structure to get a specific item when we don't know where it is or even if it exists at all. And finally, can we sort the contents of the data structure so it's in some kind of meaningful order? And that's whether we want to sort it in place or we want another copy of it that's sorted. And these 5 things would cover 99% of everything you'll ever need to do with any data structure. But let me tell you, folks, we often won't get all 5 and don't expect to. For example, many data structures don't support any kind of searching behavior. It's just a big collection, a big bucket of stuff. If you need to find something, you just programmatically go through all of it yourself. And many don't provide any kind of sorting behavior. Others are naturally sorted and can keep themselves organized. And we're about to talk about the basics of sorting and searching. But as I've gone through here with these resizable arrays, and will prove to be true with many of the later data structures we've got coming up, to add a new item to a data structure will typically be some variant of the word add, insert, or push, and to pull an item out of a data structure, it'll be some variant of the word remove, delete, or pop.